Hey gang, wanted to jump in and mention a few things, given some feedback. Don't overthink things, but at the same time, you have to know your notation. And that was something I talked about very early on in the semester, all the way back to chapter 1, where you've got to know your definitions and you've got to know your symbols. You have to know what they mean, so that things like this don't look so overwhelming. It's actually very simple what it's stating. And then the rest of 8.2 is not too bad in accordance, especially if you can do chapter 7 well. So let's walk through that. There were two criteria so the sampling distribution of the proportion can be approximately normal. One is that the sample be less than 5% of the population size. That's all this means, okay? This is a guarantee of independence. For this particular problem, we're told that the population proportion was 0.17. Okay, that just means that 70% of the population has a credit card. And then it says that they sampled 300 people. So little n is the sample size. The first criteria for the sampling distribution to be approximately normal is that the sample size be less than 5% of the population size. You might be saying, well, we don't know the population size. Well, you do know the sample size. So we need 300 to be less than or equal to 5% of the population size. Okay, that means in order to solve for what the population size would be, we just divide both sides by 0.05. It's just a little bit of algebra, right? Okay, and to divide by 0.05 is to multiply by 20. So that simply requires that the population size be greater than or equal to 6,000 people. And that's true of every nation in the world except for the Vatican, which is technically a sovereign nation, but let's be honest, it's probably not the focus of this study, right? So we're going to consider that to be true. The other is that n times p times the complement of p be greater than or equal to 10. And this actually has to do with the binomial distribution, which is kind of at the roots of this proportion stuff. So with the first criteria checked and true, all we need is for n times p times its complement to be greater than or equal to 10. And you don't have to know anything deep about this. All you have to do is literally plug the numbers in and see if it's true. So we do 300 times 0.17 times 1 minus 0.17, and we find that that is 42.33, which is definitely greater than or equal to 10, so the second criteria is good. So why do we care that those are good? Well, because it means that the sampling distribution is approximately normal. Which means, as long as we find the proper mean and standard deviation of the distribution, we can literally use Chapter 7 techniques to answer the problems that they ask us about. And fortunately, they even told us what those would be. The mean of the sampling distribution is going to be exactly the population proportion, and the standard deviation of the sampling distribution is going to be the square root of p times 1 minus p over n. Right? And once you calculate those, you can literally plug this in for the mean and this in for the standard deviation in StatCrunch and find probabilities the same exact way you did in Chapter 7. So now that I know the mean of my normal distribution is 0.17, which is the same as the population proportion, and the standard deviation of my sampling distribution is 0.022, right, which is the square root of the quantity p times 1 minus p over n, they ask me, what is the probability that in a random sample of 300 adults, what's the probability that less than 15% have no credit cards? So we're trying to find the probability of a sample proportion being less than 0.15 in an approximately normal distribution with a mean of 0.17 and a standard deviation of 0.022. Okay? Now, notationally, this is literally exactly the same as saying, what's the probability in a normal distribution with a mean of 0.17 and a sigma of 0.022, what's the probability the random variable takes on a value of less than 0.15? Who cares that when in StatCrunch it's saying x? It's just saying what's the value of the random variable, and the random variable in our particular case is the sample proportion, right? But they mean the same thing. So in StatCrunch, I open up my normal calculator. Okay? And I say, hey, my distribution is normal with a mean of 0.17 and a standard deviation of 0.022. And I want to know the probability the random variable takes on a value less than 0.15. What's that look like? Oh, just like the stuff we did in Chapter 7, who cares that the mean is a proportion between 0 and 1? Don't let that throw you off, guys. We're using the same techniques we learned in Chapter 7. We're just learning about different distributions that have some of the same characteristics. That's why we studied the normal distribution in Chapter 7, so that we could apply it to different scenarios.